So in this another problem, we are going to solve one problem based on super mesh. So what was super mesh? We have discussed previously that if one current source as shown here, so if one current source is common to two mesh, then we are going to apply the super mesh here. Now what the question is saying, in the given circuit find the mesh currents, and the mesh currents are given like this one is mesh 1 and this one is your mesh 2. So we have to find this mesh current values. So before finding this, we need to apply the mesh analysis here, and to apply the mesh analysis, as here one 6 ampere current source is there which is common to, so 6 ampere current source is what? Current source is common to mesh 1 and mesh 2, mesh 1 and mesh 2. So for that we have to apply what? We have to apply super mesh here. So when applying super mesh, as I have told, so we will not consider this part in the circuit for putting the mesh, and we will combine mesh 1 and mesh 2 as a single loop. So how to write the equation? So if I write the equation here, 20 volt is there, so I will write 20 minus 6 into I1 because I1 is flowing there, minus here 10, so 10 into I1 minus 4 into I1 is equals to 0, sorry 4 into I2 and 10 into I2, not 1, is equals to 0. Then what we can write? So that implies your 20 minus 6 I1 minus 14 I2 is equals to 0, or else we can write this as simplifying 6 plus I1 is equals to I2. Okay, sorry, not this one. Yeah, so this can be written as 20 equals to minus 20 is equals to 6 I1 plus 14 I2, and I will take this as, let us say, equation number 1. Now next we can see here, so this 6 ampere value. So what is this 6 ampere value? So if I consider mesh 1 here, so I1 current is flowing like this and I2 current is flowing like this. So I can write that here 6 plus I1 is equals to I2. Okay, so like this I can write. Why? Because I can apply the node here, nodal analysis here at this point. So if I apply the nodal analysis at this point, then what I will get? So I1, so if I am considering nodal analysis at this point, so this is outward I1, then this is outward, this is inward as I2, and this is outward at, so let me clear this and write again. Yeah, so if I apply nodal analysis here or the KCL here, so here it is I1, and this place what it is 6, and here I2 is coming. Okay, so I2 is inward and I1 and 6 are outward. So I can write 6 plus I1, that is equals to I2. So if I apply this equation 2, let us say, if I apply this equation 2 in equation 1, so that implies I can write 20 is equals to 6 I1 plus 14 into what? I2 value I can write as 6 plus I1. Okay. Now if I solve this in with the help of calculator, now you can see here that I1 is the single variable here. So for here I can solve value of I1 will be equals to 3.2 ampere. Now you should calculate these values with your calculator and you verify these answers, and I2 value, from if I put 3.2 ampere here as I1, then I2 value I will get as 2.8 ampere. Okay, so this is how you can apply the mesh analysis for super mesh technique. So when the super mesh technique is applied, if there is a current source which is common to two nodes, if one current source will be here, then there is no need of applying super mesh, you can do it directly. So this is how you can solve it, and I will be solving one new problem in the next video.